Hi everyone, this is Dr. Nak, and today we're going to be learning about solving quadratic equation by completing the square. Now, in our previous section, we learned how to solve the quadratic equation by applying the square root property. So let's just recall what that was all about. So you were asked to solve something of the form ax squared plus bx plus c equals to 0, and you were given something like maybe x minus 5 squared equals to maybe 25 or something like that. Then if I want to solve for x, remember we took the square root on both sides, and here we're going to get x minus 5 equals to plus or minus the square root of 25. So we got x minus 5 equals to plus or minus 5. So that implies that x is 5 plus or minus 5, which implies that either x is 5 plus 5, which is 10, or x is 5 minus 5, which is 0. So that method was called the solving the quadratic equation by applying the square root property. Now, in this section, you're also asked to solve something of the form ax squared plus bx plus c equals to 0, but the method is going to be different. The method that we're going to be using is this thing called the completing the square. So before we go over this, let's just take a look at something like this. X plus 9 squared. Now, if I have to multiply this out, this means that we're going to have to multiply x plus 9 twice. So this means we get x squared plus 9x, and then plus 81. So which gives us x squared plus 18x and then plus 81. So multiplying this was pretty much piece of cake. Now what is the completing the square? Well, we're going to have to work it backwards. So given something of the form x squared, let's just take this one since we did it. Given this, our job is to do something magical to make this into a perfectly squared quantity. So what we're going to be learning in this section is that the magical portion of it, where if you're given the second degree trinomial, you want to try to come up with a perfectly squared quantity. That method is called the completing the square. Let's just do some examples. So let's take a look at example 1. Complete the square to make a perfect square trinomial. Then write the result as a binomial squared. You're like, say what, right? So basically this is what we're going to be doing. Our job is to come up with some number here so that when I add in this number, we can make this trinomial into something of the form x, I'm not sure this is going to be plus or minus, of something whole quantity squared. So I'm just going to straight up and teach you how to do this. So let me take a look. So I'm going to copy down the problem. So now in order for us to come up with that magical number that you need to add on the left, what you need to do is this. Divide the middle number by 2. Always by 2. Then what we're going to get here is negative 26 divided by 2, so that will be negative 13. Yes, you must include the sign as well. Alright, now what goes in here, which means that the magical number that you need to add is nothing but negative 13 squared. That's the quantity that you need to add in. So what's negative 13 squared? That's positive 169. So I need to add here 169. So the left-hand side now becomes the trinomial of degree 2. Now, let's work on the right-hand side. Now, I want to make this into a binomial squared, something that's perfectly squared. So this is what's going to happen. Well, let's just set this guy up as something whole quantity squared. You better have x in here, no matter what. Now, what goes in here is nothing but this number. So you're just going to insert this number in here, including its sign. So this is going to become x minus 13. I just wrote too many steps here, so let me just clean it up a little bit. So this is what happened. Let me just rewrite it as x squared minus 26x. Okay, so if I add 169 to it, on the right hand side is going to be x minus 13 whole quantity squared. Alright, so if you don't believe it, let's check. So let's expand this side. Okay, so x minus 13 squared means x minus 13 times the x minus 13. Alright, then here you're gonna have x squared minus 13x minus 13x, and then plus 169. Alright, so then this becomes x squared minus 26x plus 169. Isn't it exactly what you're given here? So this method does make sense. So what the question's asking you is to come up with this number and then also come up with the perfectly squared quantity. So this is the number that you need to add in to make it into a perfectly squared quantity of x minus 13 whole quantity squared. Let's do another one. So let's complete the square on m squared minus 20m. So again, what we want is we need to come up with some magical number that you need to add in to make this into a, in this case the letter is m. So something of the form m plus or minus something something whole quantity squared. Alright, so let's take a look. So I'm going to copy and paste what we're given. Alright, remember the steps? Step 1, divide a middle number by 2 including its sign. Then you're going to have negative 10. Now, what do you need to add in? Well, just the negative 10 whole quantity squared is the quantity that you need to add in. So in this case, what's negative 10 whole thing squared? 100. So you're going to have to add in 100. Now, left hand side is done. Now let's work on the right hand side. Since the right hand side must be a perfectly squared quantity, our setup is going to be something whole thing to the second power. Well, you better have m in here. Alright, so now what goes in the rest of the parenthesis is nothing but this number right here. So that's the number that's going to go in. So I'm just going to insert minus 10. So let me just rewrite it in same color. So this implies that m squared minus 20m and plus a 100 equals to m minus 10 whole quantity squared. Okay, so if you don't believe me, then let's check. Alright, so if I expand this out, this means m minus 10 and then m minus 10. If I multiply this, you get m squared minus 10m minus 10m and m plus the 100. So we get m squared minus 20m and then plus 100. So it matches up. So therefore our answer is going to be this. Alright, let's just do another one to make sure that you're understanding this. So let's go with part C. Okay, so please pause the video and try this problem on your own. And I'm going to start working on this. So let's do the same thing. Given this, I'm going to divide a middle number by 2. So here you're going to have negative 3 over 2. Don't hate just because you got a fraction. You got this. So what do you need to add in? Negative 3 over 2 squared. So that would be positive 9 over 4. Now on the right hand side, you better have something whole quantity squared. First term is going to be x. Now remember what goes in the rest of the parentheses? It's this number right here. So it's going to be negative 3 over 2. So that's all you have to do. So if I write this nicely, we're going to get x squared minus 3x plus 9 over 4 equals to x minus 3 over 2 whole quantity squared. Hopefully you guys got this problem right. And if you're okay with that, let's move on. So now what we're going to do is we're going to be solving a quadratic equation of the form ax squared plus bx plus c equals to 0 by completing the square. So let's go with the step 1. Make one side of the equation to be 0. Okay, and then step 2, you need to come up with the magical number that you needed to add to complete the square. So for example, in part C that we just did, that magical number is 9/4. And step 3, add that magical number on both sides of the equation. And then step 4, write the left side of the equation in perfectly squared form. And step 5, apply the square root property to solve for x. I think the best way to do this is by examples. So let's take a look. Example 2, solve by completing the square. So let's take a look at part A. X squared plus 4x equals -21. So what we need to do on the first step is to make the right hand side or the left hand side, usually the right hand side, equal to 0. So how do I do that? We need to add 21 on both sides. So the first step is to make this into x squared plus 4x and then plus 21 equals to 0. Now, one more thing that I did not mention is that in order for you to complete the square, the leading coefficient, so which means that coefficient on x squared must be 1. So meaning this number has to be 1x squared. Okay, so here's what I would do. I usually start off with rewriting this trinomial by x squared plus 4x and leave a little room, and then plus 21 equals to 0. All right, so what we're going to do on the left hand side is to complete the square. So what do? We divide this number by 2, then we're going to have +2. And then what goes in here is +2 whole thing squared. So which would be +4. Now notice that if I'm going to add 4 on the left hand side of the equation, I better do the same thing on the right hand side of the equation. So here I'm adding 4 to both sides. That 4 is that quote unquote the magical number. Now that first 3 terms on the left hand side of the equation, which is these guys, is going to form a perfect square. So I should be able to write this in terms of something perfectly squared, and then you better have an x. Now what goes in on the rest of the parentheses was nothing but this number, if you remember. So here you're going to have to go +2. Okay, then drop down that plus 21, and then right hand side is going to be 4. Now from here, what we're going to do is we want to apply the square root property to solve this equation. So first, I need to subtract 21 on both sides. Then we're going to get x plus 2 whole quantity squared equals to -17. Now applying the square root property, taking the square root on both sides, then we're going to have x plus 2 equals plus or minus the square root of -17. So from here to here, what we did was applied the square root property. Okay, so now let's keep going. So this implies that we're going to have x plus 2 equals to plus or minus the square root of 17 times the I. And 17 is a prime, so you cannot simplify that. So next step, subtract 2. Then we're going to have x equals -2 plus or minus the square root of 17i. Okay, so therefore, our solution set is going to be -2 plus square root of 17i, and then -2 minus the square root of 17i. Don't worry, if you didn't catch this one right off the bat, we're going to do more examples. Oh, before that, just in case you kind of got lost how x squared plus 4x plus 4 became the x plus 2 whole quantity squared, let's just go back to what we just did on example 1. So I just rewrote it in a different way, and that's all I did. So remember, if I had an x squared plus 4x, if I had to complete the square, what you have to do is divide the middle number by 2. So you're going to have plus 2. And then what goes in here is plus 2 squared. So that will be plus 4. Now on the right hand side, remember, I wrote this guy as x and then something whole quantity squared. Now what goes in the rest of the parenthesis was nothing but this number, wasn't it? So I'm going to have that. So instead of writing it out horizontally, I just wrote it out vertically. So do you see what I boxed in lavender color? I have x squared plus 4x, and then I have that plus 4. Now I just wrote it, this guy is going to equal to x plus 2 whole quantity squared. So I just rewrote it in a different way in case you kind of got confused there. Anyway, let's take a look at another one. Let's do y squared minus 18y equals to negative 6. So we're going to do the same step. So here, first, I'm going to rewrite this as y squared minus 18y. I need to make the right-hand side equal to 0, so I need to add 6 to both sides. And the right-hand side will be 0. Now, I'm going to rewrite this in a little bit of a different way as x squared minus 18y. Leave a little room, and I'm going to put plus 6 equals to 0. I'm leaving that room because I need to add that magical number in. So let's do it. Divide this number by 2. What you're going to get is negative 9. Now what goes in here is negative 9 squared. So that will be positive 81. Now you cannot just randomly add 81 on the left hand side, so you got to do the same thing on the right hand side. So now these three terms become the perfect squared. So this portion becomes y minus 9 squared. Again, I just plug this number here. And this and plus 6, don't forget to drop down that 6, equals to 81. Now from here, all you have to do is subtract 6 to get y minus 9 squared equals to 81 minus 6 is 75. Okay, now after you got into this form, all you have to do is apply the square root property. So if I do that, taking the square root on both sides, then we're going to have y minus 9 equals to plus or minus the square root of 75. Alright, I think 75, we need to simplify it a little bit. So let me just work it. Where can I work it? Over here. Alright, so 75, 5 is going to go in, and 15, and then 5 and a 3. So here you're going to have 5 squared times 3. So let me just work the square root of 75 as a side work. So therefore, square root of 75 is square root of 5 squared times 3. That's a 3, sorry. So this is 5 square root of 3. So this equation now becomes y minus 9 equals to plus or minus 5 root 3. I'm running out of room. You know what? I'm going to go over here if you don't mind. Okay, so now what? Add 9 on both sides to get y equals 9 plus or minus 5 square root of 3. Looking good. So therefore, it looks like our solution set is going to be 9 plus 5 square root of 3, or 9 minus 5 square root of 3. And I'm going to box that for the answer. Now let's take a look at something like this. X squared plus 10x plus 4 equals to 15. Solve by completing the square. Now, in order to complete the squared, you better have a second degree binomial, which means that only x squared plus 10x can be on the one side of the equation. So with that said, I need to move that 4 over by subtracting 4. Then we're going to have x squared plus 10x. And then I'm already going to leave a little room. And then here what we're going to get is 15 minus 4, which is going to be 11. Okay, I think we're ready to complete the square. So let's go. So first, divide this number by 2. You're going to have plus 5. What goes in here is positive 5 squared. So add in the 25. Now you cannot just randomly add the 25 on the left, so that means they better be fair and do the same thing on the right hand side. Now the first 3 terms is going to become a perfect squared. So this is going to become x plus 5 squared. That plus 5 comes from here, so that's this plus 5, equals to 11 plus 25. So what the heck is that? 36. Okay, now apply the square root property, and we're gonna get x plus 5 equals to plus or minus the square root of 36. So now let's subtract by 5 on both sides, and I guess we can simplify the square root of 36 to 6. So what we're gonna get is x equals to negative 5 plus or minus 6. So that implies that we're gonna have x equals to negative 5 plus 6, which is 1, or x equals to negative 5 minus 6, which is going to be negative 11. So I think we're done. So therefore, our solution set is going to be 1 and negative 11. So I'm just going to box that for the answer. All right, so let's do more examples. Remember, practice makes perfect. Let's take a look at something like x squared equals 3x plus 11. Now again, in order to complete the square, you better have x squared and 3x on the one side of the equation. So what I need to do first is to subtract 3x to get x squared minus 3x. I'm already going to leave a little room, equals to 11. All right, ready? Now divide the middle number by 2. It's negative 3 over 2. What goes in here is negative 3 over 2 whole quantity squared. So what we need to add in is plus 9 over 4. Now again, you cannot just randomly add 9 over 4 on the left hand side. You better be fair, do the same thing on the right hand side of the equation. Now this first 3 terms is going to become a perfect squared, which is x minus 3 over 2 squared equals to 11 plus 9 over 4. Now don't hate just because you see that fraction. 9 over 4, it's super cute. It's not bad at all. All right, so to add these two together, remember you need to get the common denominator. So I'm going to put that as 4. That means that I need to multiply 11 by 4 to get 44. So what do we get over here? We're going to have 44 plus 9, which would be 53 over 4. Okay, so let me just rewrite this nicely. So we have x minus 3 over 2 squared equals 53 over 4. All right, now apply the square root property to get x minus 3 over 2 equals 2 plus or minus the square root of 53 over 4, which is same thing as plus or minus the square root of 53 over the square root of 4, which is 2. Now, since 53 is a prime, we cannot reduce that anymore, so I'm just going to leave it the way it is. Now, last step, add 3 over 2 to both sides, and then we're going to have x equals 3 over 2 plus or minus the square root of 53 over 2. All right, I think we're done. So therefore, our solution set is 3 over 2 plus square root of 53 over 2, and 3 over 2 minus square root of 53. That's a 53. Ugliness. Hold on. Oh, well, you can read my handwriting by this time now. All right, so that's going to be our solution set. All right, now let's take a look at something that looks kind of different. So let's solve x minus 3 times x plus 5 equals to 9 by using the completing the square. So first, I need to get the x squared and then the x term on the left-hand side. So guess what we need to do? Yes, we need to FOIL it. We need to multiply that out. So that's our first step. So if I do that, we're going to have x squared plus 5x minus 3x and then minus 15 equals to 9. So you get x squared and then what is that? Plus 2x minus 15 equals to 9. Okay, now to complete the square, I need to isolate x squared and 2x on the left. So I need to do is add 15. Alright, so then what we're going to get is x squared plus 2x. I'm already going to leave a little room. Equals to 9 plus 15, that's 24. Alright, now we're ready. Step 1, again, divide this number by 2. You're going to have positive 1. And then what goes in here is positive 1 squared, which is just positive 1. If I'm going to add 1 on the left-hand side, I better be fair and add 1 on the right-hand side. Now, the first 3 terms going to become the perfect square. So this portion is going to become x plus 1 squared equals to 24 plus 1 is 25. Alright, so now apply the square root property in your head to get x plus 1 equals to plus or minus the square root of 25. Alright, so now what do we get? So that implies that, so let me just simplify this to plus or minus 5 already. So looks like we're going to have to subtract 1 to get x equals negative 1 plus or minus 5. Okay, so that implies that either x is negative 1 plus 5, which is 4, or x equals to negative 1 minus 5, which will give us negative 6. So our solution set is going to be 4, negative 6. And I'm going to box that for the answer. How you all doing up to here? Hopefully you're getting it, because now what we're going to do is to learn how to complete the square if the leading coefficient, meaning the coefficient on the x squared, is not 1. But we got this. It's not as bad as you think. So let's just do some examples. Let's look at 3x squared minus 12x minus 15 equals to 0. Great. We already have a 0 on the right hand side. So what we need to do is we need to make that 3 into a 1. How do I do that? Well, you can think of it as divided by 3 to every single term, or you can think of it factor out the 3. So if I factor out the 3 to rewrite this, then here what we're going to get is x squared and then what? Minus 4x and then minus 3 times 5 is 15 equals to 0. So far so good. Now what? I need to get rid of that 3, so maybe I should divide this whole thing by 3. So that will kill this, and then divide it by 3. And 0 over 3 just becomes a 0. So if I rewrite this again, x squared minus 4x minus 5 equals 2. So this is 0, so I'm going to have a 0. Now, does it look familiar? So now what we're going to do is we're going to do the same thing as what we did in example 1. Sorry if I hear that barking noise on the background. It's just my little baby Moku. But anyways, so let's do it. So first what we need to do is we need to isolate the x squared and then the 4x on the left hand side. So we need to add that 5 to both sides. And we're going to have x squared minus 4x. I'm going to leave a little room equals to 5. All right, we're ready to do this. Let's complete that square. Divide this number by 2. Jeez, you're going to have negative 2. Now what goes in here is negative 2 squared, which is going to be plus 4. Now if I'm going to add 4 on the left, I do the same thing on the right. Now, first 3 terms going to become the perfect square. So here what we're going to get is x minus 2 squared equals to 9. Applying the square root property, then you're going to get x minus 2 equals to plus or minus the square root of 9. So this is plus or minus 3. So what do we get? X minus 2 equals to plus or minus 3. That's what we have so far. So add 2. And I'm running out of room, so I'm going to go over here. So that implies that we have, what do we have now? X equals 2 plus or minus 3. So that implies that either X is 2 plus 3, which is 5, or X equals to 2 minus 3, which is going to be negative 1. So I think we're good to go. So our solution set is going to be 5 and negative 1. It's not too bad, is it? All right, so let's do another one. Let's try this one. 2x squared minus 3x equals 20. So first thing first, I need to make that leading coefficient 1. So again, you can think of it as factoring out the 2 if you like, or you can think of it in dividing by 2 on both sides. That's totally fine with me. So since we factor out on the example A, so let's just divide it by 2 on example B. So what I'm going to do is I'm going to divide this guy by 2, but if I'm going to do that, I better be fair and divide everybody by 2. Then let's rewrite. Now we have x squared minus, don't hate, 3 over 2x equals 20 over 2 becomes 10. All right, now we have x squared and an x term on the left hand side, so we are ready to complete the square. All right, so let's do it. Again, we're gonna divide the middle number by 2. All right, so now you're probably freaking out. So just write it out. You got this. So this means what? Negative 3 over 2 divided by 2, isn't it? So how do you do that? That's same thing as negative 3 over 2 multiplying here by the reciprocal of 2, which is 1/2. So that number is going to become negative 3 over 4. Okay, so what we need to do now is to add in negative 3 over 4 squared. So what is that? Plus 9 over 16. All right, now if I'm going to add in 9 over 16 on the left, we're going to do the same thing. Plus 9 over 16 on the right. All right, so now the first 3 terms are going to become the perfect squared. So let me see. I don't know if you can follow my work. So you're going to have x, and then the next number that's going to go in is this guy. So you're going to have minus 3 over 4 whole quantity squared equals to 10 plus 9 over 16. Okay, we can do this. So now we need to get the common denominator. So I believe that the common denominator is 16. So let me just work it here. 16, 16, and this guy is going to become 9. So now what we need to do is multiply 10 by 16 to get 160, which gives us 169 over 16. All right, let me rewrite this nicely. So what do we got? We have x minus 3 over 4 squared equals to 169 whole thing over 16. All right, now apply the square root property. Then we're going to get x minus 3 over 4 equals to plus or minus the square root of 169 over 16, which is same thing as plus or minus square root of 169 over square root of 16. I'm so sorry. Can you read my handwriting okay? My handwriting is kind of getting nasty there. Sorry, I'll try to write it nicer. So here, what's square root of 169? Is that 13? So here you're going to have plus or minus 13 over square root of 16 is 4. Okay, again, let me just rewrite what we got so far. So we have x minus 3 over 4 equals to plus or minus 13 over 4. Okay, so one more step. Add 3/4 to both sides. Then we're going to have x equals 3 over 4 plus or minus 13 over 4. So this implies that either x is 3 over 4 plus 13 over 4, which is going to give us 16 over 4, which is going to be just 4. All right, or our x is going to be 3 over 4 minus 13 over 4. So this becomes minus 10 over 4. Always reduce your fractions. So 2 is going to go in to 4 twice, into 10 5 times. So here what we're going to get is negative 5 over 2. Okay, so we're done. So therefore, our solution set is 4 and negative 5 over 2. So let's box that for the answer. I know that many of you don't like to deal with fractions, so guess what? Let's practice another one that's going to involve some fractions. Let's take a look at 7x squared plus 4x equals negative 3. Okay, so do we have x squared and then the x term on the left? Yes. So now what we need to do is we need to make that leading coefficient to be 1. So what we need to do is divide by 7 on each single term. So let's do it. Divided by 7, divided by 7, divided by 7. All right, then what do we get? X squared plus 4 over 7x, I'm going to leave a little room already, equals to negative 3 over 7. Do not panic. We got this. All right, ready? We're going to divide a middle number by 2. So here what you're going to get is 4 over 7. Oops. Divided by 2, which is same thing as 4 over 7, multiplying here by 1/2. Now 2 is going to go into 2 once, into 4 twice. So what do we have left over there? That's positive 2 over 7. All right, now what's going to go in here is positive 2 over 7 squared. So which will be 4 over 49. Then we're going to do the same thing on the right hand side. We're going to add 4 over 49. Now the first 3 terms going to form a perfect square. All right, so now what we're going to get here is x and then plus 2 over 7 whole quantity squared equals negative 3 over 7 and then plus 4 over 49. Okay, we can do this. So the least common denominator will be 49. Let me write it as 49 and then 49. So here we're going to have a 4. And for the other fraction, I guess I need to multiply the top and the bottom by 7 like this. All right, then numerator is going to be minus 21, which is going to give us negative 17 over 49. All right, now let's take this, before I take the square root, let me just rewrite this nicely so you can follow my work. So now we have x plus 2 over 7 whole quantity squared equals negative 17 over 49. Now, applying the square root property, then we're going to have x plus 2 over 7 equals plus or minus the square root of negative 17 over 49. Okay, we got this. So this is same thing as plus or minus the square root of 17 over square root of 49 times the I, which is plus or minus, well, 17 is a prime, so I'm just going to leave it like that. And then square root of 49 is 7, and then I. All right, let me rewrite it again. So we have x plus 2 over 7 equals to plus or minus square root of 17 over 7 I. All right, one more step, hang in there. So now we subtract by 2 over 7 on both sides. Then what do we got? We got x equals negative 2 over 7 plus or minus the square root of 17 over 7 I. See, easy peasy, we got this. So therefore, our solution set is going to be negative 2 over 7 plus square root of 17 over 7i. And what do we got? Negative 2 over 7 and then minus square root of 17 over 7i. So I'm going to box that for the answer. And we're done. Alright, I am completely done with completing the square section. So if you have any questions at all, please let me know. And do not get discouraged by dealing with fractions, because look, if you're able to follow what we just did, that means that you're totally understanding everything. So tell yourself that you got this, and you just gonna have to become one with the fractions. But trust me, if I can do it, you can do it too. So again, if you have any questions, please let me know. And good job, you guys.